Alright, so this could be our next notes in quadrilaterals. And so far we've been looking at different shapes like what a quadrilateral is, you know, a polygon with 4 sides. Then we looked at rectangles and looked at some tests for different shapes and parallelograms. And now we're looking at some different types of parallelograms, so different ways to describe them. And we're going to look at a rhombi, a rhombus, and a square. So there's some basic rules to understand to help you decide which one you have. And probably the square is the easiest one to understand. But if we're going to first start here with rhombus, let's see what it says. So a rhombus is a parallelogram with 4 congruent sides. Now if you think about that, that's a square too. 4 congruent sides as well. So we have to add some things to it to make it different and show how a rhombus isn't exactly a square. Okay. So first one is, we're going to add 2 conditions here. So if we draw diagonals on a shape and they are perpendicular, then that helps us determine that it probably is a rhombus. Okay. So a square is not necessarily going to give you that. And then the second thing we look for is when the diagonals bisect, you get a pair of opposite angles. So opposite angle can be a couple things. It can be like, these can be vertical angles too, but these are like opposite angles. 2 lines intersect and we have opposite angles. But opposite angles can also be 2 angles that are equal to each other. So this is saying if you have a rhombus and you have a diagonal bisecting that angle, then it dissects it or bisects it into perfectly, and each of those angles are equal to each other. So we'd have angle 1 and 2 is equal to each other, 3 and 4, 5 and 6, and 7 and 8, wherever that bisector is. So that's a rhombus. We have the diagonals are perpendicular, and the diagonals bisect a pair of opposite angles. Okay. And then we have a square. So a square is a parallelogram that is 4 congruent sides and 4 right angles. Okay. Now, there's a difference here. If you look back at the rhombus, is that it has 4 congruent sides as well. But the difference is, if you draw the diagonals, you get a perpendicular angle there. And if you did the same with these diagonals, so if the diagonals bisected this here, you could also get 2 angles that are equal to each other as well. Okay. In fact, all of these would be equal to each other. When we look at this one, that might not necessarily be the case. We might have these 2 angles are equal to each other, these 2 angles, but they're not all equal to the same angle. Okay. So, and what's really interesting when you think about a square, and you think about rectangles we've looked at that are parallel sides, at least the 2 opposite sides are congruent, but not all 4 are congruent. So, but the thing that's similar about a rectangle and a square is it does have 4 right angles. Okay, so if we're looking at a quadrilateral that's a rectangle and a parallelogram at the same time, it'll have 4 right angles. Okay. And then we look at a rhombus, it has 4 congruent sides. Okay. So if we combine them together, that's how we get a square. So if we have something that has 4 right angles and something that has 4 congruent sides, then we get a square. So then we look at some conditionals to understand whether we have a rhombus or a rhombi in a square. The first one is, if the diagonals of a parallelogram are perpendicular, then it's a rhombus. Right? That's kind of the first thing we talked about. And it also says if one diagonal of a parallelogram bisects a pair of opposite angles, then it's a rhombus. Okay. And then also, if one pair of consecutive sides of a parallelogram are congruent, then it's also a rhombus. And finally, if we can prove that a quadrilateral is a rectangle and also meets the requirements for a rhombus, then it also means it's a square. So those are the kind of things we want to keep in mind. We're going to review some of this in class. Just add all this to your notebook. Maybe check out your textbook as well. And the last thing we have to look at here is using a coordinate system to prove whether something's a rhombus or a square or a rectangle. Okay. We're going to use some basic ideas. So the first thing when we're using coordinate geometry, we're going to want to take whatever points we have and put them on a graph so we can look at it. So I've done that here. Right? We have these points, and I've put them on a coordinate system. We have K, L, M, J, or J, K, L, M. I put it on here, and I can kind of look at it, and I can kind of see that this is not a square. Okay. And then, and it might look like maybe it's a rectangle, maybe it's a rhombus, or all these sides equal to each other. I could figure that out. I could also use some diagonals as well and compare them to see how they compare to each other to see whether I have a rectangle, a rhombus, or a square. So that's kind of what we're going to do. So we're going to use the distance formula, and we're also going to use slope to see if these things are parallel as well. And so let me put some numbers in, and then we'll get started on this last part. So I've added some important information that you want to make sure you get in your notebook. Some of this is kind of review. So if you remember when we were looking at rectangles, one thing we know about rectangles is that the diagonals are congruent. Okay, so if we draw diagonals from J to L and K to M, and they're the same distance, then we would know that this is a rectangle. Okay? And then, if we then check the slope of these, and they are perpendicular, then we'd know it's also a rhombus. And then finally, we know if it's a rectangle and a rhombus at the same time, it's also a square. So first thing we'll do is say, are these congruent? So if we did like KM, I'm just going to do a rough draft here, right there, and then we do this one right here. So if we compare those two, and they're the same, they don't look the same to me. One looks a little longer, but then we'll do the math and figure it out. So the first one we did KM, and we just did, looks like start with m2 minus 0 for x, and we square it, and then negative 4 minus 4, then we square it, and we get square root of 68 for all that. If we then look at JL, we would then get, looks like negative 7 plus negative 9, 16 squared, then be 256 plus, this is 4 squared, 16, then we get the square root of 272. They're not the same. Okay, so this doesn't look like it is a rectangle at all. So no rectangle. So the next thing we want to do is figure out their slope. So let's do that next. I'm going to pause. I'm going to put some info in here, and then you can follow along with me and see what you got as well. So if I plug in the slopes here, so I'm going Km, what's the slope of this? And then JL, what's the slope of that? And I should get, if they're perpendicular, they should be opposite and inverse, right? So I put in the numbers for y, and I get negative 4 minus 4, I just change the sign and add. It's negative 8 over 2. That gives me negative 4. That's the slope of this one right here. And then do JL. Okay, so then I get negative 2 minus 2. I'll just change the sign and add. It's negative 4. And then I have negative 7 minus a negative 9. So I'll make it, I'm sorry, minus 9. I'll change the sign and make it negative 16. Okay. So then when I cancel this out, it would be 1 over 4. So then I see I do have the inverses. So then this tells me that the diagonals are perpendicular. Okay. So that tells me rhombus, right, as well. Okay. And then I just need to check one more thing, and I would be good. And I could check my sides to see where that leads me. Let me do that, and then we'll be done with the notes. So then I'm just going to do the distance formula for this one and this one. Now, you might think, well, why don't you just do this one and compare, and this one and this one? Well, these might be the same. But to make sure it's a rhombus, if I do this one and this one, they're not parallel, so they're consecutive sides, and if they're congruent, then I know that these are all the same, right? So let me do that. I'll put that down here. So the distance formula for JK, let me actually put these numbers in. Pause again. Okay, so I got my figures written in here. So I got from J to K, I'm just going to do the distance formula. I'm going to say negative 7 minus 0, that's going to be squared 49. And then negative 2 minus 4, negative 2 plus 4 is negative 6 squared, 36. So that's going to give me square root of 85. Okay, and then I'm going to look at KL over here. I'm going to say 9 minus 0 is 0 or 9. You square that, you get 81. And then this one, you get 2, change the sign and add them. 2 plus a negative 4, it's going to be negative 2 squared, that's going to be 4. And that's going to be the square root of 85. So I know those sides are, I know JK and KL are the same, they're congruent. So then I know that they have the diagonals are perpendicular by my calculations, and then I know these sides are congruent as well. So then I know I have a rhombus. Now if I checked these angles and figured out that they were at 90 degrees, and I would do that through slope as well, I would figure out a square. But we can see obviously that they're not 90 degrees. So that's your kind of introduction to rhombus and squares. Add this to your notebook and see you tomorrow in class. Make sure if you have any questions, write them down and ask them. We'll also go over the homework as well. See you there.